Now, the topic of discussion is cells, electromotive force and internal resistance. So, before we get into the topic of electromotive force and internal resistance, let's try to understand what exactly a cell is, what is present inside a cell. So, in your lower grade, you would have learned that cells are sources of energy. So, what energy? They are the source of the electrical energy which supply to the remaining part of the circuit. So, generally, how are cells represented? Cells have an anode, which is a positive terminal, and a cathode, which is going to be a negative terminal, right? So, cells have two terminals, and how are they represented? One long line and a small line. You have a positive and a negative. Now, the topic that we are going to concentrate for cells is we are going to understand what exactly happens internally and how is it able to provide energy to the remaining part of the circuit. See, generally, let's say there is a cell which is connected across an external resistor. Let's say the cell is connected across an external resistor. If suppose I give you the potential difference across the cell is 1.5. Now, the first point we need to understand is there is a slight difference that is existing between the term potential difference and EMF. Okay. So, let's first look at the definition of EMF, then we will revisit what is this 1.5 volt. So, what is EMF? Look at the definition. EMF of a source is defined as the amount of work done. So, here it is defined as the amount of work done by whom? By the source itself. Here the source I am trying to talk about is the cell. The amount of work done by the source in doing what? In taking a unit positive charge from lower to higher potential, right? If you look at this definition is something similar to the potential difference we have learned in the second chapter. In the second chapter, we told like the amount of work that needs to be done to carry a charge from one point to another is what we call it as potential difference, right? Now, here this 1.5 volt, we need to raise a question. Am I trying to speak about the potential difference or EMF? Because both of them have a similar definition. So, this is where the confusion starts. So, let me be clear on this. If suppose you go to an electrical shop and you ask for a cell. Let's say you go to an electrical shop and ask for a battery or a cell. Here, let's take this as a cell. Now, what will be the specification you will tell the person? So, you will say, give me a cell which is of 1.5 volt. Now, what is that you are reporting to the electrical person there? So, are you reporting the voltage? That is, are you reporting the potential difference or the EMF? This is the question. So, many of them think that they are telling the potential difference of the battery. But remember, a battery which is not connected across any device will not have a potential difference across it. It will have a term called as EMF across it. So, this EMF is what is called as an electromotive force. Okay. So, how can you relate EMF in terms of potential difference? Because if you observe, EMF is also measured in terms of volt. As I told you, when you say 1.5 volt to the shopkeeper, you are talking about EMF, right? Now, how will you try to define electromotive force in terms of potential difference? So, you can define it like this. EMF is the potential difference across the cell. Remember, EMF is defined only for the cell, whereas potential difference can be defined across the cell as well as across a resistor. So, EMF is the potential difference across the cell. The cell is also called as the source. Potential difference across the cell in open condition. So, what do you mean by open condition? When this battery or the cell is not connected across any external circuit. So, what generally happens is, if the cell is having an EMF of 1.5 volt, let's say it is supplying a current I, right? So, when can you say the circuit is complete? So, when is it said to be a closed circuit? When the current flows through the wire, it flows through the external resistor, it flows through the wire again, and it comes back to the negative terminal of the cell, right? So, here the charges are actually flowing. Now, what exactly is supposed to happen? So, the direction of current is taken the direction in which the positive charge tends to move, right? It means if there is a positive charge, then the positive charge is tending to move in the anti-clockwise direction according to this diagram. As soon as it reaches the lower potential of the cell, what exactly is going to happen inside the cell, right? Till now what we were doing is we were analyzing only the external part of the circuit. Now we need to understand what exactly happens inside the cell and how is this EMF able to make the current flow through the circuit. So now we will revisit the definition again. So how do you define the EMF of a source? Source means here the cell is defined as the amount of work done by the source in taking a unit positive charge from lower potential to higher potential. Means if you look at the cell, a cell has a positive terminal and a negative terminal. So if this is positive and negative terminal, so from positive to negative, what is the force that is going to exist? There will be an electrostatic force. But if you look at the real-time cells, all the real-time cells are generally made up of chemicals inside them, though they have electrolytes. So within the electrolyte, what is constituting to the flow of charge? It is the what are the majority charge carriers? They are nothing but the ions present in the electrolyte. So if you take a positive charge, right? If let's say when I told you the current is reaching here, once the current reaches here, that is the positive charge reaches here, the positive charge needs to get carried in the leftward direction. That is what the definition is saying. Amount of work done by the source in taking the unit positive charge from the lower potential to the higher potential. This has to be achieved so as the circuit is completed. So who is doing this work? This work is done by a force which is non-electrostatic. It is nothing but the chemical energy that is present within the cell. It is trying to push the positive charge from the positive to the negative terminal, that is against the electric field. Okay. So the work done by this force, so work done, let me say the distance of separation between the electrodes is D. The work done by the non-electrostatic force multiplied by the product of the force by the non-electrostatic force multiplied by the distance will give me the work that is done by the source. If I divide the work by charge, then this is what is called as potential difference. Recollect, potential difference means amount of work done per unit charge. So Fn into D divided by Q, if I am able to define a parameter like this, then this potential difference in the open condition is what is called as EMF. This is the mathematical expression for EMF. Generally we don't use this formula Fn into D divided by Q because these values will not be given to us. They will directly give us the value of EMF, and EMF is represented by the symbol E. Sometimes we write it, some books represent it in the terms of epsilon also. Next, the term internal resistance. Now if you look at the circuit has a resistance R. See, generally the resistor R, which is connected to the battery through the help of a wire, is what is called as an external resistor. So it is an external resistor. Okay. Now, what do we mean by internal resistance? We need to understand what is the internal resistance. So as I told you, every cell has an electrolyte present in it. So when you have electrolyte, you will have ions. Along with the ions, there might be some neutral particles which are actually not dissociated. Now, when the positive charge is trying to go from the lower potential to the higher potential, and who is doing that? Due to the chemical force, it will experience some resistance within the cell. Okay. Remember, every cell will offer some internal resistance. Every cell will offer some resistance to the charges which are flowing internally. So since the resistance is offered inside the cell, the name is given as internal resistance. So generally when you see, internal resistance is represented by the symbol R. Okay. Now, if you need to define electromotive force in terms of a closed circuit, as I told you, when can you complete the circuit? When the charge starts from, let's say, from point A and comes back to point B, and from point B it should be able to reach A at least one time. Okay, that is when the circuit is said to be complete. That is the meaning of closed circuit. If the charge is starting at A and stopping at B, then we cannot say that the current is complete. Okay. Now, keeping that fact in mind, in a closed circuit, how do we define EMF? EMF of a source can be defined as the energy supplied by the source in taking a unit positive charge once around the complete circuit. When I say once around the complete circuit means when the positive charge has started from point A, it should come back to the point A. So what are all the journey, what is the journey it is undergoing? So the journey the particle is undergoing is, it is going from A to B, right? So A to B means the charge particle is traveling from the higher to the lower potential through the wire and lower to the higher potential within the cell. So when this happens, when the particle starts at A and comes back to A, we say it as a closed circuit, and we call it as one complete circuit. So this is all about EMF and internal resistance.